Okay, so this is the second video of the structure of physics um, participation assignment. And what we're trying to do in this assignment is create a functional structural organization, a structural organization that ties pieces of information together about what we're going to be learning this year, main concepts. And we've talked about the idea that this will enhance our learning because it allows information to be learned through connecting one piece of information to another in a logical way rather than just simply trying to memorize it. Um, and we said that we were going to start with a very basic core of basic ideas, and through the core ideas, we're going to uh, connect to more and more detailed pieces of information in our graphic organizer. And so the study of physics revolves around the relationship between three main concepts. And I'm going to put the answers in the Nearpod notes section um, so that you can see them while we're uh, doing this. And what we say is our core is that energy gives rise to forces which give rise to motion. So energy which gives rise to forces which give rise to motion. And this makes sense. There's no memorization involved in this. It's just something that makes sense. Energy is the direct cause of forces being exerted, and the forces being exerted are the direct cause of motion occurring. Okay, so that's going to be our core idea, and that's what we'll start our graphic organizer with. And let's look into this idea in a little bit more detail. Okay, so first consider the term energy. I'm sure you've heard a definition for the term energy. It's a very simple definition. It's the ability to do work. Okay, now this is actually a really good definition for energy if you know some things about physics, but if you don't, my guess is that most of you think it's at least unclear and maybe even uncomfortable. And why do you think that's the case? What is it about this particular definition that makes it unsettling? Okay. Um, and just in listening to answers related to this, the most unsettling thing about this is that the the words ability and work are unclear in what we mean in this definition. Okay, it's not clear in this definition what the words ability and work actually mean. It's very vague, and in order to feel more comfortable about it, it would need to be defined a little bit more thoroughly. So let's say that that's the case for um, the number 5 blank here. What is it about this definition that's unsettling? The meaning of the words ability and work. The meanings of the words work, ability, and work are very unclear in this definition. Okay, so that'll be the answer for 5 that you give. Okay, now we can make this idea of energy seem a little bit more real and or a little bit more substantial if we decide that that one way we can measure or see what an amount of energy looks like is by finding out how much work we can do with a certain amount of energy. We're going to find out how much work we can do with a certain amount of energy. So if I throw a baseball, you are aware that after the ball leaves my hand, it can be stated to have a certain amount of kinetic energy. In other words, the energy of motion. Once I have an object that's in motion, the fact that it's in motion makes it gives rise to kinetic energy, or the energy of motion. Okay, so let's make a little drawing here of this up at the top. Okay, so we've got the baseball leaving my hand and flying off, and it's got a certain amount of kinetic energy. Okay, so That's our starting point, and we're going to relate the amount of kinetic energy to an amount of work that occurred. So go ahead and go to the next slide. Now recognize that to get the amount of kinetic energy that I have, I had to do the same amount of work on the ball. In other words, as my hand was throwing the ball, the hand was doing work on the ball. And the same amount of work that I did on the ball will end up being the same amount, will end up being the amount of kinetic energy. So however much kinetic energy the ball has, once it leaves my hand, that's how much work my hand did on the ball. So what unit do we measure energy in, first of all? And you can see in the notes over there I've written joules for number 6. So that's what goes in your participation worksheet. So if the ball ends up with 100 joules of kinetic energy, I had to do 100 joules of work on the ball to accomplish that. So let's illustrate that. Okay, so I've shown there that in order to get 100 joules of kinetic energy for the baseball, I had to do 100 joules of work on the baseball with my hand. Let's go ahead and go to the next slide. So we may not have a good idea of what the ability to do work really means, but we have a starting point here. We do know that if we have 100 joules of kinetic energy, okay, that somehow 100 joules of work must have been done to create that. Say that again. If we have 100 joules of kinetic energy, somehow 100 joules of work must have been done on the ball to create that. Okay, so go ahead and go to the next slide. Now, does the ball that has 100 joules of kinetic energy have the ability to do work? Again, does the baseball that has 100 joules of kinetic energy have the ability to do work? Of course it does. And the definition of energy tells us this, right? Energy is the ability to do work. Therefore, if I have 100 joules of kinetic energy, I have the ability to do work. So the question is, how much of an ability? And of course, the answer is 100 joules. If I have 100 joules of kinetic energy, I can do 100 joules of work, the same amount as the amount of energy the ball has. So that ball that has 100 joules of kinetic energy can do 100 joules of work. Let's go ahead and go to the next slide. The next question then is, how does this energy accomplish doing work? How does the energy accomplish doing the work? The answer to that is that the energy is converted to a force. Okay, the energy is converted into a force. Would you agree that if I throw the baseball at a milk jug in a carnival game, if it hits the milk jug, it will apply a force? The answer to that is obviously yes. If the baseball hits the milk jug, it will apply a force. Yes, with an exclamation point. Again, energy gives rise to a force. But how much of a force? Well, first of all, what are the units of force? Do we remember? Units of force, the units of measurement for force are newtons, named after Isaac Newton. Okay. Let's go ahead and go to the next slide. Now, because the amount of work done on the jug by the baseball has to equal the amount of energy the baseball had, and we're assuming a direct hit here and that all of the energy of the ball is transferred to the jug, we're saying that the ball did 100 joules of work on the jug. So one of the many things that we'll learn in this class is that work done on an object equals the force applied to the object times the distance that the object then travels. Okay, and that's a very simple mathematical formula. Work equals force times distance. So if the jug travels 1 meter and 100 joules of work was done on it, the force applied to the jug must have been 100 newtons. It's actually a little bit more complicated in this, but we'll go with this for the purposes of our story. The point is we can connect the amount of force applied with the amount of energy through the work done. Okay? So just to kind of remind ourselves now, I did 100 joules of work on the baseball, and the baseball obtained 100 joules of kinetic energy, and then the 100 joules of kinetic energy impacted the milk jug, and 100 joules of work was then done on the milk jug. And because the jug went 1 meter, force times distance, the force would have been 100 newtons. Okay, let's go to the next slide. But there's more. The energy gave rise to the force, but what did the force give rise to? And obviously that was motion. Okay, question is how much motion? So the jug was initially at rest, and then all of a sudden it was in motion. How fast was it going the instant after the ball hit it? What was the acceleration? So because we'll learn an even more important relationship between force, acceleration, and mass, that is, acceleration equals the force applied to an object divided by its mass. The jug had a mass of 1 kilogram and the force applied was 100 newtons. We could figure out the acceleration, and from that we could figure out the velocity of the jug right after the ball hit it. So we have this amazing relationship between energy and force and motion. So that's why we have this core relationship. Energy gives rise to forces, which give rise to motion. Let's go to the next slide. So I don't expect you to know all of this for some time yet, but this does illustrate the central theme of all of physics. Energy gives rise to forces which give rise to motion. And this becomes our starting point then for our graphic organizer, which will outline all of the stuff that we're going to do this year. Okay, so when you think about this, think about the example of the baseball. The baseball had 100 joules of kinetic energy, and that gave rise to a force on the milk jug, and that force gave rise to motion. Okay, so, and we can relate the amount of energy to the amount of force, we can relate the amount of force to the amount of acceleration. So go ahead and go to the next slide. So this is the beginning point of our graphic organizer. And if you're doing this at home, I would ask you, even though you've got a copy of the complete graphic organizer that we have, we want to actually physically build this graphic organizer, because that's the part of this that makes it effective for you to actually write this out. Okay, so on a sheet of paper, and you're going to put this in the middle of the sheet of paper, so that there's going to be a fair amount of room above and below and to the sides of this. So let me just draw a square around it to show how much room to leave. Hold on. So this is about the amount of room that you'll need on your graphic organizer. And this is a separate sheet of paper, right? You're going to submit your drawing to me through Canvas, and you're also going to submit the worksheet that you're working on through Canvas as part of this assignment. Okay, so go to the next slide. Actually, we're close enough to our 15 minutes that we'll just stop here and begin with another video starting in the next section. Okay.